So, are you trying to troubleshoot or understand how a high-pressure sodium light, also called an HPS Luminaire, works? Maybe one's not turning on, or maybe it keeps flickering. Don't worry, we're going to explain it step by step in plain English. Let's get started. First, it's important to know that HPS lights are part of the group called HID lamps, or high intensity discharge lamps. This includes mercury vapor and metal halide lamps too. But HPS fixtures have one special part that others don't: the starter. That's what makes HPS troubleshooting a little different. Here's the deal. When you flip the switch on an HPS light, it doesn't just light up instantly like a regular bulb. It needs a huge jolt of electricity to get going, anywhere from 2500 to 4000 volts. But wait, the power coming out of your wall is only 120 or 240 volts. So how does it jump that high? Enter the starter. This little device boosts the voltage just long enough to get the lamp started. Like a car starter. Once the lamp is running, the starter shuts off and stays off until the lamp is turned off and restarted. Here's a key point. If your high-pressure sodium lamp is cycling on and off, it might not be the starter's fault. In fact, the starter could be working perfectly, trying to restart the lamp over and over. One common mistake: mixing starters, ballasts, and lamps that weren't designed to work together. High-pressure sodium starters come in different shapes. Some look like circuit boards, others look like plastic cubes, but they all do the same thing. That said, they're tuned to specific wattages and lamp types. If you mix the wrong ones, your lamp might start unreliably or not at all. Think of it like pairing a remote to your TV. Sure, it might turn on, but you won't get all the right functions unless they're made to work together. Let's explain how the starter works using a car engine analogy. In a car, you have spark plugs that ignite fuel. You have breaker points that open and close to generate a spark. You have a coil to boost the voltage, and a condenser or capacitor that helps with the timing. An high-pressure sodium starter works in almost the same way. The arc tube electrodes act like spark plugs. The electronic switch is like the breaker points. The capacitor helps boost the voltage, and the ballast acts like an ignition coil, ramping up voltage like a mini transformer. So when you first turn the light on, the capacitor charges up, the electronic switch closes briefly, the capacitor dumps its energy into the ballast, the ballast steps up the voltage to thousands of volts, the lamp ignites and you have light. And once a lamp is up and running, the voltage drops and the starter turns off automatically. It only comes back on if the lamp shuts off and needs to restart. Let's talk a bit more about the ballast, because it's a real workhorse of a high-pressure sodium luminaire. During startup, the ballast helps generate that high voltage spark. But once a lamp is running, its job shifts. It regulates voltage and current so the lamp doesn't overheat or burn out. Here's how the voltage behaves. Before the lamp starts, Voltage is about 110 to 120 volts. Right after startup, voltage drops to 15 volts. After a few minutes, as the lamp warms up, it climbs to a steady 44 to 62 volts, depending on the model. Here's something to remember. Once the voltage drops below 100 volts, the starter cannot operate anymore. That's by design. It prevents the starter from sending high voltage spikes while the lamp is already running. If you're trying to fix or troubleshoot a high pressure sodium light, this is crucial to understand. If the lamp cycles on and off, it's not always the starter. If you've mixed incompatible ballast starters or lamps, you'll get weird symptoms. If the lamp isn't starting, check that the starter is matched to the fixture and the capacitor is good. And remember, even though the starter looks like a small part, it's handling thousands of volts. So be careful. Always disconnect power before inspecting or replacing components. Let's do a quick recap. HPS fixtures use a starter to produce a high voltage spike, just like a car's ignition system. Once the lamp starts, the voltage drops and the starter shuts off. The ballast plays two roles. It helps start the lamp and then regulates it during operation. Mismatching starters, lamps, or ballasts can lead to poor or no starts. Cycling lamps are often a sign of lamp age or voltage rise, not a faulty starter. Easy way to remember, think of it like a car. Starter equals ignition system, arc tube equals spark plug, ballast equal coil and voltage regulator. Start it up, then back off and let it run smoothly. And that's it. Now you've got a solid understanding of how HPS lights start, run, and what to check when they don't behave as expected. Thanks for listening, and remember, always match your parts and let the starter do its job. Until next time, stay safe and stay bright.